Good afternoon, ladies and gentlemen. Welcome to the IFR press conference here in Germany, in Frankfurt. I will present you first of all the schedule of this event. After the introduction of the panelists, Gemma will report on the global robot market up to 2020, and afterwards Wyatt will inform you about the latest trends in the robotics industry. And then you will have the time to put your questions to all the panelists. Just a few words on the International Federation of Robotics. We had a turnover in 2016 of 40 billion US dollars. We have more than 50 members, national robot associations, robot suppliers, robot integrators, as well as research institutes and universities. We are the sponsor of the oldest conference, oldest robotics conference, the International Symposium on Robotics, which will take place next time in June at the Automatica in Munich. And we are co-sponsor of the ERA Award, which honors inventions in robotics which are already commercialized on the market. And we are the primary source of the worldwide data on the robotics market. Now I would like to introduce the speakers. So Gemma, he is the IFR president, and he is also president and CEO of KUKA Robotics, United States. And Wyatt, he is a member of the IFR executive board, and he is group vice president and head of marketing and sales robotics of ABB Switzerland. And myself, I am the General Secretary. My name is Gudrun Litzenberger, and now I give the floor to Joe.
So on behalf of the IFR and the thousands of members that we represent, we thank you for coming here today. And we appreciate the opportunity to present this information on the global robotics market before making it available to the general public. The exciting growth trend continues. You can see that the slide shows a very nice incline, and in fact, we expect an additional 1.7 million robots to be installed by 2020. That compares to roughly 950,000 in the previous 4-year period. Exceptional growth. And that growth will continue at a rate of 15% from 2018 through 2020. As you can see by this slide, we had a sales record of 294,000 robots in 2016. And that also continues a trend of setting new records for 4 years in a row. It also indicates we've almost doubled since 2012. Now, major industries impact certainly that growth, and for us, the two main sectors driving that growth are the automotive markets and the electronics markets. The two of them combined are roughly 2/3 of the global total market. And electronics is certainly leading the way, as you can see by this chart, with a very large growth of 41% year over year from 2015 to 2016. It remains, in fact, a very important market in Asia, and that is led through Japan, the Republic of Korea, and certainly China. And like in 2015, the auto industry also saw an increase in 2016 to a record level. It has slowed slightly over the last 2 years, though, compared to the exceptional growth from 2010 to 2014. Still, the automotive market remains the major customer of industrial robots, with approximately 35% of the total market share. Asia, and we talk a lot about Asia, so certainly we saw that the strongest growth in Asia across the world, and that is led by China. In 2017, the robot installations in China are expected to grow another 21%. I mean, in the Asian and Australian region, sorry, they're expected to grow 21%, but not alone. The Americas, they're expected to grow in 2017 at 16%, and Europe is also expected to grow approximately 8% in 2017. And some of the important drivers to that are robot adoption, more acceptance to robots, and is responding to faster business cycles, greater variety of products driven by consumer demand, and this is in multiple sectors. So we're seeing other areas growing in other markets. And from 2018 to 2020, we expect an average annual growth in Asia of approximately 15%, in Europe approximately 11%, and in America 15%. I think it's interesting to note that Asia by 2020 will be more than double of both America and Europe combined. The market is across multiple countries, as you can see by this chart. However, 5 areas dominate that with 74%. As you can see, the top 5, China, Republic of Korea, Japan, United States, and Germany. China significantly expanded its leading position as the biggest market in the world, which is approximately 30% of the total in 2016, which equated to 87,000 industrial robots, twice the next biggest market. And consider in 2009, there were about 60,000 globally and 87,000 alone in China last year. Again, the others that I mentioned, Korea, Japan, the US, and Germany combined are 44% of the total supply of the world market. So that, along with Asia, China is 74%. That growth we expect to continue right through to 2020, and we expect by 2020 that China will have 40% of the global supply in the market. And China's domestic robot suppliers continue to expand in their home market. It is now, as of 2016, 31% of the robots installed in China were domestic suppliers. And China intends to forge ahead and move into the top 10 of the world's most intensely automated nations in 2020. That market offers a huge potential for a variety of robot installations in the future in a variety of market areas. As previously mentioned, we expect double-digit growth. In 2017 alone, we expect 32% in China. And from 2018 to 2020, an average growth between 20 and 25%. The next one in the markets, as I said, the largest, Korea now, the Republic of Korea being the second largest market. And it's seen major investments in the electronics industry, considerably since 2010, in fact. And if you look, it's twice as compared to 2012 to 2016 now. And South Korea is the highest level of robot density in the world. It has 631 robots per 10,000 employees in manufacturing as of 2016. The country is the market leader in LCD and memory chip manufacturing, which embraces automation technologies for effectiveness in the market space. It will continue with large projects planned in both the electronics and automotive industry in the near future. We expect an average 5 to 10% growth over the next 4-year period, 2017 to 2020. Japan has rebounded. It's a 35% growth from 2013 to 2016. And in 2016 saw a 10% growth over 15, up to 38,600 units. And that's the highest since 2006, which was 37,400. Japan continues to be the dominant robot manufacturing country. And since 2010, production has doubled to 152,000 units in 2016, driven by replacement, new materials, new production processes, increased capacity requirements in the electronics industry, and this will result in considerable worldwide sales going forward. Japan has their own project called Japan's Robot Strategy, which will further stimulate growth there and certainly support it abroad. In 2017, we expect further growth there at 9%. And then through 18 to 2020, a pace of an average of 5% per year. The USA in 2016 set another record. And you can see from 2010, more than 100% growth. In 2016, with 14% growth, brought it to a peak of 31,400 robots. And domestically, the trend to automate, allowing for the strengthening of American industries to compete in the global market, is affecting the installation of robots in a positive way. And we expect that in 15% growth on average 2017 through 2020. It's certainly, the automotive industry is a major player. In fact, the automotive and OEMs and the suppliers continue to be the driver of automation technologies in the US, in North America, with approximately 75% of the market there is automotive and automotive suppliers. However, the electronics market is gaining there also, especially with Foxconn's LCD display manufacturing plans leading the way. Germany, a very stable market, and in fact, the automation engine of the European community. It is, in fact, the #2 and second most robot density in the world, with just over 300 robots per 10,000 manufacturing employees. Germany did see a slight increase in 2016 to just around 20,000 robots. We, the IFR, still see an opportunity for growth there and expect from 2017 to 2020 an average of 5% growth per year. The majority of that coming from the general industry and the automotive industries. By 2020, and that's part of our job, is to give you a view of the future, we expect there'll be 3 million robots in operation across the world. And that estimate goes from 1.8 million in just over 1.8 million in 2016 to over 3 million by 2020. This will be due to an average growth of 15% per year, year to year over that period. In 2020, of that 3 million I just spoke of, there'll be 1.9 million in the Asian Australian markets. And that will account for even bigger majority in 2016 already, 17 already, with a 16% increase in operational stock. Some of the growth drivers beyond the countries I already mentioned are Taiwan, India, Vietnam, and other Southeast Asian countries. And I mentioned about the 2020 expectation of 1.9 million in operation in that region. That's almost equal to what the total current operational stock is in the world today. In 2017, we also expect an increase of 9% in America, with Mexico emerging and adding to more value to that from an automation perspective. And finally, about a 7% increase in Europe due to significant contributions from Central and Eastern Europe, and certainly some of the traditional markets in that area. In 2020, again, I said 3 million across the world, 1.9 million in Asia. Half of that in Asia will be in China. China alone will be operating 950,000 robots by 2020. And that's actually approximately 50% more than Japan. I mentioned Japan because Japan, up until 2015, was the largest operational stock in the world. although that does continue to grow in that area, also in Japan. I mentioned robot density in a couple of my previous comments. Robot density globally continues to increase, and Korea by far is the highest. I mentioned earlier 631 is double the next closest country, which is Germany, and then right behind that, Japan. Robot density in China is the most dynamic due to the rapid growth we've seen in recent years. Still below the global average of 74 per 10,000 manufacturing employees. China particularly saw some significant growth in the period of 2013 to 2016, where it went from 25 robots per 10,000 to 68 per 10,000. USA also saw some significant increase, especially since 2010, and went from 114 robots per 10,000 workers to 189 robots per 10,000 workers in 2016. In addition, France, Taiwan, and Spain also saw some marked increase in that period. So some of the trends that Steve will be talking a little bit about is the Industry 4.0, where we expect to play a bigger role, as well as machine learning, AI, and collaborative mobility. Simplification of programming, ease of use strategies will drive more acceptance and more new applications. Robots offering precision, connectivity will play a key role in digital manufacturing of the future and smart manufacturing. With increased availability and affordable costs that enable more manufacturing companies of all sizes and all sectors to automate. I thank you for your time and attention. Now I invite Steve Wyatt to tell you a little bit more about the trends in the industry.
Thank you, Joe. Good afternoon, everyone. So, my name is Steve Wyatt. I have the privilege to serve on the executive board of IFR. And what I would actually like to do is try to complement what Joe has talked about, primarily around the statistics, give you a little bit of a feel for some of the trends that we see going on in the marketplace and what that potentially implies in terms of what robots in the future will look like, and also what robots will actually have to do. So if I start with what I typically refer to as the changing nature of manufacturing and work, I think in order to understand what it is that robots will potentially do, or what they will do in the future, we first have to look at what is the environment in which they operate, and what are the changes that are actually taking place there. So if I was to highlight a couple of factors that are rather critical here, one is the fact that actually, due to all of you in this room today and all of you attending virtually, there is a change, fundamental change taking place in manufacturing from what I call high volume and low mix to low volume and high mix. The fact that none of you that sit next to one another, don't look too guilty about it, actually want the same thing as the person sitting next to you. But the one thing you do have in common is you all want it now. And that drives a fundamental change in the infrastructure of manufacturing, which has really been set up to produce an awful lot of a very limited number of things. One of the other things that is actually changing is there continues to be and will continue to be an acute shortage of skilled labor. If we take Japan, that Joe mentioned as one of the main companies in robotics, one of the historical drivers, 20% of the current labor force in Japan today will retire within the next decade. And that will bring also about fundamental change in the manufacturing setup of that country. And maybe all of this underpinned by what I refer to as the digital generation, or maybe the millennials if they want. Millennials, they actually don't want to do the same type of jobs that the baby boomers who are currently setting off into the sunset and their well-deserved pensions were happy to do. They do not like what I often refer to as these 4D tasks, things that are dangerous, delicate, dirty, and dull. Those are not things they aspire to. They want to do more meaningful work, and they are much more interested in being able to use their cognitive skills and not do the types of dangerous, delicate, dirty, and dull things that a robot can actually do. So if I try to put this into something maybe a little bit more scientific, we have a lot of engineers within our members, so I try to put it into a little bit of a form that hopefully everyone can relate to. Here I try to take some of these trends that I've mentioned. Then I actually move a little bit into some of the challenges that this actually represents for our industry. And then if I look at what I call the enablers, here I try to address a little bit some of the things that many members are working on with great creativity in order to try to unlock what is really a huge opportunity actually for us in the market. If I pick one of these examples, you'll be happy to hear I'm not planning to go through everything, but if I can pick maybe just this example of SMEs, these small, medium enterprises. So actually SMEs, they make up 99% of the companies in the EU and the US. And actually they account for 2/3 of the jobs in the private sector. But actually, if we're brutally honest with ourselves, they struggle to deploy our robots. They find them a little bit too complex and a little bit difficult to use. Bear in mind, these are typically companies that are often 1 or 2 employees. They go anything from machine shops to butchers to bakers. They have a lot of competence, but not typically with robots. So that's why if we look at some of the simplicity in terms of programming, ease of use, more intuitive programming, these are things that our members are working on that will actually help us to unlock this opportunity. And that will actually help us to move this industry forward, actually from the very nice growth rates that we have today to the next phase of growth in this particular industry. Now, if I try to summarize a little bit that example that I just gave on SMEs, as well as some of the other examples you see on the sheet, I would say that you can try to categorize, bucketize, whichever word you like, into what I often refer to as simplification, digitalization, and collaboration. So if I may, I try to just give a couple of examples of what that actually looks like in practice for people in the robotics industry. And then I try to bring some concrete examples of how we see that actually transitioning into practice. So simplification. If I talk about simplification, traditionally, and even today, robots are programmed. And they're typically programmed with proprietary programming languages. Today, however, we're actually able to start to teach robots using something which we would, many of us would refer to as lead-through programming. So the example here being that if you would have a robotic arm attached to a tablet, for example, and you take the robot and you lead the robot through the steps that the robot needs to do. So move from position 0 to position 1, collect object A, move to position 2. So every time you hit one of those points, you simply click on your tablet, it will record it, and at the end you hit save, and you hit go, and then the robot will run the routine that you saved in the tablet. So we're managing to take robots from programming into lead through, and then ultimately, moving forward, robots will also be able to set themselves up, and they will be able to optimize themselves. So there's an example of simplification that I hope you can see can relate to a small medium enterprise, where that particular company will have very limited capability in terms of robot technology. But it also applies equally to large enterprises. If you look at some of the large global conglomerates, they're also interested in simplification, but simplification means something different to them. For them, they are constantly challenged by the fact that they're asked to produce. As a result, again, of all these people in the room, you will see that we are to blame. It's a bit of a recurring theme today, because they need to produce closer to where the product is consumed. The consequence of that is they end up with many more locations. We have many customers amongst their members that are 300, 400 locations across the globe, and they desperately need a simple, standardized solution so that when they produce the same product across the globe, what the consumer ends up with will be exactly the same. You need to have the same quality and consistency so that the brand, whether you buy it in Brazil or in Indonesia, you will see exactly the same thing. So simplification is important to different categories of company that use robots, but it is not interpreted or required in the same way. If I move on to digitalization, so I'm sure you're probably even much more familiar than me with a whole slew of terms that are used to describe this, anything from Internet 4.0 here in Germany to the industrial Internet of Things and many other terms to boot. I would say actually what this is really about is taking the connectivity that we all take for granted in our pockets, in our handbags, that we have in our homes, and actually moving it into the industrial world and using that to make our professional lives in industrial premises and industrial locations actually much more simple. If you look at what happens today and what will happen moving forward, this will be very much enabled by vision and sensing technology, some of it coming from the gaming and the mobile phone industry that has been adapted to the robotics industry. And that will enable us to collect data, which then via analytics we'll be able to use to improve the operations and the efficiency of our operations in factories. It will also help us to develop new business models. So for example, a lot of these sensors that collect data, with the analytics that we are then able to run on that data, we will be able to look at condition monitoring, so the health of the factories that are running, as well as predictive maintenance, trying to figure out at what point does it actually make sense to carry out some maintenance, rather than just looking at the normal annual shutdowns that are simply run or traditionally run by companies. And that in itself will also help to increase the uptime, the efficiency, and the productivity of industrial locations and also companies. One thing I would also like to underline at this point, Joe mentioned it also, machine learning. It's a term that also can mean different things to different people. But fundamentally, machine learning will be at the center of a lot of things that robotics will see in the coming years. I will give you some examples later in how we see that actually running. And this itself will also be enabled by things that you're also, I'm sure, quite familiar with by now, cloud platform, big data analytics, and such like. Last but not least, if I move to the third bucket, the one that I refer to as collaboration. So since so-called collaborative robots burst onto the scene a few years ago, I think a lot of us in the industry, and certainly here at IFR, we've learned that they actually mean different things to different people. So for some people, it's about what I think the initial concept was meant to be. It's about robots that are actually able to work safely together with people without the requirement to be behind a fence or a cage. There are other people, however, simply look at it as something which is actually able to be easily programmed, to be easily installed. Yet others, such as my favorite SMEs, that actually don't require a robot that does the same thing 24/7. So there they consider collaborative robots as something which is relatively easy to redeploy. So they can do one thing with the robot in the morning and potentially use the robot to do something else in the afternoon. I think the one thing we can, however, say is that for the first time we have robots and machines that are able to collaborate, robots and humans that are able to collaborate together safely. It has opened up a whole number of options for manufacturing, how we think about it, how we potentially design for manufacturing. And as Joe mentioned earlier, it is an area that is developing quickly and will continue to move forward at great pace in our industry. So in trying to conclude, what I would like to try to do here is to give two examples of how you can potentially try to see these things in practice. So if I look at my first example, I call it self-optimizing production. And what is actually meant here, this is something for the factory managers of this world. So this relates to a scenario where a company has 10 or 15 locations throughout the world. And they have a common operation, let's call it palletizing. We have a robot that is part of a palletizing cell that is putting bags onto a pallet and packing them up. One of the challenges that people have today is, first of all, it's very difficult for them to see how these palletizers are performing in different parts of the world, to understand if there are any differences, and also what we can do about that, how we can optimize it. So through a combination of connectivity and machine learning, here we have the capability to connect all these things to a network. Now, you might tell me if I'm an SME, I may not have a network. If I'm a large company, I probably do have a network. But I can connect to that network. I can connect all of these robots. At the click of a button, I can see exactly how my palletizer in Sao Paulo, Brazil is doing, how that compares to the one I have in Memphis, Tennessee, or the one in Jakarta, Indonesia. And with the data that I generate, I can actually use it so that the robots that are not doing so well, but performing the same task, just in a different location, that they can learn from the others in order to increase the overall efficiency and productivity of my factory. These are things that were not possible in the analog world, and these are things that will be very possible in the digital world. In fact, they're already starting to happen today. Second, and my last example, it relates actually to what I call self-programming robots. So here, the scenario is a little bit different. So if you look today at a robot installation, so you have a robot, but that robot then, if I stick with my palletizer example, it will need some kind of end-of-arm tooling or gripper, as we would commonly refer to it. There may be some feeding or conveying that's required. It typically needs to then be engineered, it needs to be installed, it needs to be commissioned. And at the end of the day, that final cell will typically be about 4 times the cost of the actual robot itself. So there's a great interest from these companies to try to find a way not only to reduce cost, but actually also to get that robot up and running much faster. So in this particular scenario here, what happens is you have a robot. Let's take my palletizer example. So the robot connects to the cloud or to the network. If you're an SME, as I said, you may not have so much of that. If you're a larger company, you may. And it says, I'm a palletizer. I need to palletize 15 kilogram bags, and I need to put 30 of them on a pallet, and I need to do it in this time, and the bags are this long and this wide and this high. So there will be a library or a series of routines. If you're an SME, you probably don't have one of these. You will maybe call on one of the robot suppliers who will have a lot of experience in palletizing, and they will have collected that in a library. And if you're a large company, so my example of Jakarta and Sao Paulo and Memphis, there you can call on all the experience you have in palletizing. You will download that to the robot. The robot will actually start to work, and with the data that it generates, it will send it back to the cloud. We'll do some nice analytics, and we'll actually help the robot to be a little bit smarter. So at the end of the day, we've made the operation simpler, we've also made the operation more effective, and the operation is for sure digitalized. So those are a couple of examples of things that are either happening now or will be happening in the near future. I would be lying if I said that these are happening every day in every single factory across the world. But that's actually one of the reasons why I'm so passionate about robotics and so confident about the future. Because if you look at the nice growth numbers that Joe actually presented today, actually none of these things that I really talk about here are included in any significant way in those numbers. These are all things where we only just start to scratch the surface. And it's actually one of the reasons why myself, my colleagues, and our members are very enthusiastic and feel that actually in the future for robotics, the best is yet to come. So on that note, I will conclude the formal part of the proceedings. For those joining us via live stream, this will now be the end of the live stream transmission. So I would like to thank you very much for your interest in our industry, in the International Federation of Robotics. Thank you for your time and attention, and wish everyone a good day. Thank you.